if you could go back in time to any period, I imagine that means geological period. When would it be, and what species would you like to see? That's a good question.
Well, I suppose, I mean, any child would say the age of dinosaurs, and that's certainly a good candidate. But actually, I think I would go back to the origin of language, not very far, because I'm fascinated by language being. God, look at this! Hundreds of people here.
I know there's a lot of people. Yes, good for you.
We are told that all human languages today are highly complicated, equally complicated. Yet there must have been a time when they first started, when they were just rudimentary and just beginning, and I'd love to know what that was like.
Tell us that story about the salinity of our blood and how we know what we know about it.
This is a quote from J.B.S. Haldane, the great biologist, geneticist, and he speculated that the reason why our blood is salty is that it is an ancestral relic from ancestral seas. And he even made the point, which I think may be a little bit far-fetched, that the sea in those days was less salty than it is now, and that's why our blood is less salty than the sea is now.
Oh, so it wasn't that they know the salinity of the Devonian seas and our salinity matches it?
I think he might have made that up. I mean, I don't...
Oh, okay.
I don't know that.
Okay, it does sound remarkable, going back 400 million years.
He was a great Scottish biologist.
Oh, okay, there you go. Tell us, what was it about Elvis Presley that so captivated 15-year-old Richard Dawkins? Hello, everyone. And welcome to an evening with Richard Dawkins. Allow me to introduce myself. I am Carolyn Porco, and I am coming off recently a 40-year career working on two of NASA's most iconic missions, interplanetary missions. One was the beloved Voyager mission that toured the outer solar system in the 1980s and went on to continue into the galaxy and will ride the high seas of the interstellar space forevermore. And the other was the joint American-European Cassini mission that in 2017 ended a 13-year tour of the Saturn system. So you might be wondering, excuse me, why someone with a career in space exploration is going to be interviewing the UK's preeminent evolutionary biologist. And I thought that I would tell you the story of how Richard and I met. So in late 1998, a panel discussion was held on the grounds of Warner Brothers Studios in Hollywood, organized by an outfit called the Sloan Foundation. And this was a nonprofit organization that was dedicated to supporting science and to strengthening the public's understanding and engagement with science. And they had this idea that it would be good to get Hollywood folks and scientists together to discuss what Hollywood might do to improve the public's view of science and scientists through their choices of stories and characters and so on. And Richard and I turned out to be two of the scientists that were chosen to participate in this panel. And it was so long ago that I can't remember everybody who was on it. There were probably somewhere between 8 and 10 of us, Hollywood people and scientists. And I remember only one of the other scientists, and he was none other than James Watson of Watson and Crick DNA fame, so he was there. And on the Hollywood side, the people I recall were a guy named Richard Rhodes, who was the author of a book called The Making of the Atomic Bomb about the Manhattan Project. And that book was the basis for a Hollywood film called Fat Man, Little Boy, starring Paul Newman. And the reason why I remember Richard Rhodes is because he made the very memorable statement that Paul Newman was the most beautiful man he'd ever seen. You agree? Okay, we have some Paul Newman fans in the audience. Another Hollywood guy was the producer of ER, which was a popular TV show about emergency room doctors and nurses. And I definitely remember a fellow named David Milch, who at the time was having a spectacular run in Hollywood. He was kind of like the Hollywood wunderkind at the time, because he was the executive producer of a tremendously successful television series called NYPD Blue. And that show was being lauded for its gritty, very realistic depiction about what the lives of New York City policemen were like. So the Sloan folks had a good idea, and that was if Hollywood could improve the view that the public had of doctors and nurses and policemen and lawyers and so on, they could do the same for scientists. Well, I can tell you, right from the start, it did not go well. There was a surprising amount of disagreement about what should be done, and would it even be successful, and even whether or not Hollywood had the obligation to do this. They just didn't want to accept that it was their duty to do this. Why should they bother? And at the center of this debate was this guy, David Milch, and he made the most outrageous, incendiary statements it was outlandish. Here are some of them. Scientists are a tough sell. Their work is boring and they don't make interesting characters. Scientists have made a bargain with the devil and the public distrusts them for it. And everyone knows the science guys never got the pretty girls in high school. And I've never met a scientist who could look me in the eye. So I'm not exaggerating when I say that this turned into a raucous affair. James Watson referred to Milch as I'm going to get this right, an escapee from the Yale English department. And I myself, in what I considered to be a very remarkable show of restraint, and half thinking that Milch was going to find this funny, I called him an asshole. Well, he did not find that funny, and it went downhill from there. So I tell this story because in this battle, Richard and I ended up on the same side of the argument, pushing loudly for the cause of science and the obvious benefits to having the public understand what it is that scientists do and why and how they do it. And as a result of that alliance, Richard and I became fast friends. So back to this evening's event. As you undoubtedly know, this is Richard's very last book tour. He's going to be stepping back from the limelight. And he asked me to join him on stage. And of course, I said yes. And that's why I'm here tonight. So this is his 16th stop on a tour which started in the US 2 months ago. We're going to be discussing a host of topics, including his new book, with the terrific title, The Genetic Book of the Dead. I ask you all, please rise and welcome Richard Dawkins.
I heard a little bit of that. It wasn't easy to hear everything out in the wings, but I do remember the incident that Carolyn described. I think she whispered in my ear, "This man's an asshole."
No.
But he heard.
No. I whispered while someone else had the microphone. Because he was sitting next to me. By the way, this was written up in the New York Times. You can even go read about it. Thank God they didn't quote me. that I said that, and I found out later from the New York Times reporter that they weren't even allowed to use that word and print it. So I thought that was great. I made news that the New York Times did not see fit to print, and I think that was kind of an
the other thing
achievement.
I remember from that it was that we went on a bus ride to look at a Hollywood studio, and I was engaged in fancy footwork to make sure I sat next to Carolyn on the bus.
Well, there
you
you
know
go.
that?
I think you told me that at one point.
Okay.
Yeah, yeah. But anyway, about Milch, I whispered it in his ear that I thought he was deliberately being an asshole.
Oh, and then he spoke it out.
And then he said,
that's right.
"So now she's calling me an asshole,"
That's right,
to the whole
yes.
audience.
Yeah, that's right.
And that's how it's okay. And how did we get on this? Okay, so there's a lot to talk about, and I want to talk, of course, about your beautiful new book, which is from the same publisher, Head of Zeus, that did your last book, with lovely illustrations by Jana Lenzova, and it offers a captivating look, not just at the natural world, but at the history of it. And it starts with a fascinating premise that the bodies and the behaviors of animals, their external markings, their body plans, their means of locomotion, all of these can be read as a description of the ancestral environments that the organism in its evolution once inhabited. So two of the many examples, Richard, that you offer in this book were particularly enchanting to me, and I want you to talk about them. One is the one that exists within us, and it offers a view of what our ancestors did about 400 million years ago, back in the Devonian period. So, which is amazing to me. Like 400 million years ago, we can read that in our bodies. Tell us that story about the salinity of our blood and how we know what we know about it.
This is a quote from J.B.S. Haldane, the great biologist, geneticist, and he speculated that the reason why our blood is salty is that it is an ancestral relic from ancestral seas. And he even made the point, which I think may be a little bit far-fetched, that the sea in those days was less salty than it is now, and that's why our blood is less salty than the sea is now.
Oh, so it wasn't that they know the salinity of the Devonian seas and our salinity matches it.
I think he might have made that up. I mean, I don't.
Okay.
I don't know that.
Okay, it does sound remarkable, going back 400 million years.
He was a great Scottish biologist.
Oh, okay, there you go. He's yours. Is this true, by the way, for other animals? The other animals that...
Oh, yes. Yeah.
They have, their salinity is like the same as ours?
Roughly.
Wow.
Yes.
Okay. All right, well, another story provides evidence that some of those animals newly arrived on land, that they came out of the ocean and took up a livelihood on land. They eventually went back into the ocean, and this one blew me away. Tell us about the dolphin and its means of locomotion, and how that is evidence.
Well, yes, okay. Dolphins, of course, they're whales. They're small toothed whales, and they're among several examples of mammals that, having come out of the sea as fish, went back into the sea later as mammals. Whales and dolphins did it in a very comprehensive way, completely back into the sea. So did dugongs and manatees, by the way, totally unrelated, but they are independently, wholly devoted to life in the sea. I think what you're referring to about method of locomotion is that the dolphins, unlike ichthyosaurs, which are reptiles, extinct reptiles which went back to the sea as well, and they would have swum like a fish with their tail going side to side like that, because that would be the ancestral fish way of doing things. But mammals invented a new pattern of locomotion, which was the gallop, where they did it in a sort of horizontal gait. The spine flexes horizontally. And dolphins maintain that. And when you watch dolphins in the water, or whales, their tail is going up and down. They are galloping through the water.
That's incredible. I mean, that's just remarkable, actually. So, anyway, that's some of the stories that Richard puts in this book. Which is, of all the examples that you put in this book of this business of looking, at ancestral environments in the bodies and behaviors of animals, which is the one that's favorite to you?
Well, I devote a bit to turtles and tortoises, because they, of course, they all had fish ancestors, as we do, as all tetrapods do, and they came out onto the land. They went back as sea turtles, but then they re-emerged so they went back to the water as sea turtles, and they re-emerged on land as tortoises. So this is a doubling back. I think that may be the only example, major example anyway, of animals that started in the sea, came on land, went back to the sea, and then came back onto the land again. And they did it twice, moreover, once in the Triassic and once more recently with modern tortoises.
They can't make up their mind.
Yeah.
Okay. In chapter 8, which you had said you wanted to spend some time talking about, it's got the title, The Immortal Gene. And it's the chapter where you revisit your thesis from 1976, where you championed this idea of a gene, the selfish gene you called it, that the feature, the gene, that examined through the lens of evolution, it is the genetic material and most importantly the information it carries or conveys from one generation to the next about how to construct the animal. That is king. It's the gene is you use the word an active agent, I think you
Yes.
use that. And that this information that comes down through the ages by, genetics, genetic replication, can go on. I mean, it can happen for what, hundreds of thousands of years?
That's the point. I mean, I could have called the book, instead of The Selfish Gene, I could have called it The Immortal Gene. This was suggested to me by Tom Mashler, who was a famous London publisher. I showed him the book in an early draft, and he said, you can't call it Selfish Gene. Selfish is a down word. You have to call it the immortal gene. And that would have been very apt because of just what Carolyn's been saying. The thing that singles out the gene as the unit of selection is that it is potentially immortal. And that makes the difference between successful genes and unsuccessful genes, because successful genes really do go on generation after generation after generation in the form of informational copies of themselves. Whereas, of course, the unsuccessful ones don't. And it's the immortality, the potential immortality of the gene, which raises it above all the other levels in the hierarchy of life, whether it's the individual or the group or the species, as potential units of natural selection. It's the gene, because it is potentially immortal, that makes the difference between those that actually do survive through many generations and those that don't.
Okay, and we're talking about this because this idea has come under criticism, that there are people working, serious scientists doing serious work on, I guess, the other processes that go on in the body and in the cell, and they're saying that to call it an active agent is not quite right, because it's not really an agent, it doesn't have a purpose and things like that.
You're talking about Dennis Noble?
Well, I'm talking about that camp of people who criticize this and say it's not, that the gene does not have a privileged role in causation.
Yes.
And I want you to you and I have been talking about, but just elaborate on it.
Well, I can quote Dennis Noble. He's a very distinguished physiologist, a colleague at Oxford. He actually was my doctoral examiner many years ago, so it's rather awkward for me. He's written a book which is in many ways a fine book called Dance to the Tune of Life. And I quote, "This book will show you that there are no genes for anything. Living organisms have functions which use genes, note that, use genes, to make the molecules they need. Genes are used. They are not active causes." Now, that's absolutely wrong. It sort of follows from what I've just been saying about the immortal gene. Dennis Noble likes to put it this way, that when the body, which he sees as an immensely complicated machine, which of course it is, and he portrays it very beautifully and vividly, when it needs to make a protein, it uses the gene, the appropriate gene, to make the protein. It goes into the nucleus, so to speak, and takes down the relevant copy of the the relevant bit of DNA, the relevant book from the library, if you like, and then he uses it to make the gene. So that the genes are just tools in the same way as proteins are, or cells are, or muscles are, anything else. The body is filled with mechanisms that it uses to survive, and the genes are just among the mechanisms that it uses to survive. That is wrong for the reasons I've just given, the immortality of the gene. The genes that survive through the generations are the ones that have a causal, note the contradiction with Dennis Noble, the causal influence on the bodies in which they sit. So the reason why some genes are successful and others are not, that which makes them successful is that they have a causal influence on the body in which they sit. They cause it to be faster or have better sense organs, or furrier or less furry, or taller or shorter, or something that makes them more likely to survive. Only if a gene has a causal influence via the process of embryology on the successive bodies in which it sits does it survive. And successful ones are the ones that are good at making bodies, at making phenotypes, by virtue of their causal influence in embryology. And I stress that word causal. You might think that since we all appear to inherit hands and arms and legs, you might say, well, surely isn't the arm a replicated entity that is passed on from generation to generation? Isn't the leg a replicated entity that gets passed on from generation to generation? And the answer is no. And the key test is this: if you make an alteration to an entity which purports to be a replicator that passes immortally down the generations, make an alteration in it, then only if the alteration is passed on is it a true replicator in the sense that the gene is. If you change the arm, for example, by going to the gym and developing your arm muscles, the inflated muscles are not passed on to the next generation. If you change the gene, that means mutation. If a gene changes by mutation, then the mutation is passed on and on and on and on and on. It goes on potentially immortally. That is what privileges the gene as the causal agent in the process of natural selection.
So you should have called it the immortal gene.
Well, that's arguable, and I from time to time I think I should have called it the immortal gene. It has a poetic resonance. It's got a more kind of Carl Saganist feel about it.
It does.
I've had this argument with my Oxford University Press publisher, Michael Rogers, who's adamant that The Selfish Gene is was the right title, because it's enigmatic and puzzling and paradoxical. But it could well be that the immortal gene would have been better.
Okay.
Well, I could have called it the causal gene as well.
Okay, on to the next question. When it comes to life, there is, well, it seems to me an obvious trend, at least in the early part of the development of life, that most life grew more and more complex with time. And it's tempting to think that complexity is therefore inevitable. You will always get living organisms to be more and more complex. And it's especially enticing to think that way if you've seen, and I know you've seen, I don't know if members of the audience have seen, the complex patterns that a computer can produce following only the very, very simplest instructions for how to color a piece of graph paper going from one line to the next. Just really simple things like, if there's black up here, put black below it, or if there's white up there, do something else. Yeah. And line after line after line after line, and you get these immensely ornate, complex patterns. That seems like complexity is just something that grows out of,
yes.
So is the trend towards greater complexity in the evolution of living systems inevitable? I
think that might be a bit misleading. All that's really happening is improved vehicles for survival. And this is going to be governed by natural selection in what I've called arms races, what other people call arms races. An arms race between a predator and prey, for example, each improvement on one side of the arms race, say the prey side, they run faster. So the predators have to run faster. And then the predators run faster, so the prey have to run faster. There are arms races between predators and prey, between parasites and hosts. Wherever the threat to the animal's survival comes from entities which are themselves evolving, then you will tend to get a trend towards increasing something or other. And complexity is a pretty likely candidate for that. So complexity of the nervous system, complexity of behavior, complexity of the responses of the prey animal to the predator, or the predator to the prey. It's entirely plausible that when there are arms races, you will get increasing running speed, sensory acuity, and probably complexity as well. But remember that the great majority of living organisms are actually bacteria, and I mean, they're complex enough, but they're not complex by our standards. When we perhaps moving to your subject, Carolyn, if we speculate about the hope of discovering extraterrestrial life that communicates with us, that's got to be complex. And so we have a natural interest in complex life, intelligent life, life with advanced computational faculties. But it doesn't seem to me to be an expectation of evolution that will be the main factor that increases. Anything in an arms race that improves the survival relative to the other side in the arms race will be favored. And of course, quite a lot of evolution has nothing to do with arms races, when it's just responding to changes in the climate, ice ages and droughts and things like that. That doesn't involve complexity. That involves whatever's required to survive in the new conditions, whether it's a drought or an ice age. You may, if it's an ice age, you develop more body hair. When the ice age finishes, you lose your body hair. That's not complexity. That's responding to the environment. Wherever there are arms races, I think complexity is one of the things you would expect to find. There's also perhaps a kind of one-way valve that if you wait long enough in evolution, anything you expect may happen. And the sort of complexity that we have in intelligence and language, it's only happened once, and it only arrived in the last 500,000 years or so. It may take a long time for something like that to appear.
Well, I was going to get on to intelligence, and
Okay.
it took billions of years, in fact, after the first cell to get to at least a technologically capable intelligence.
Yes.
That's a long time.
Yes.
So it didn't happen quickly. So could it be that intelligence is
never
not
happened. I mean, there's no reason to suppose that it will happen on any planet.
So it's not inevitable.
Very far from it, I think. I mean, there are people who think it is. There's a Cambridge biologist who is very good. He's called Simon Conway Morris, as paleontologist, who actually predicts that if there is life elsewhere in the universe, it will be pretty humanoid. I mean, we sometimes criticize science fiction writers for their naivety in peopling their alien worlds with creatures that look like us. Conway Morris actually thinks they will look like us.
Well, okay, so is he like thinking the opposable thumb?
Well, more than that. I mean, I think he thinks that bipedal, big head, eyes looking forward, language.
Huh. Okay. All right, that's interesting. And I was going to say, is it a good bet that those planets that produce biospheres will also produce intelligence? But maybe not. Maybe not.
Well, I mean, this is straying to your subject, and I'd like to talk about it, but
But I'm asking you because you're the one who studies evolution. So
Yeah. Okay, well,
I mean, it sounds like you're saying intelligence is not necessarily something that will happen.
far from it, but unless it does, we won't know about it, probably.
Yeah, that's right.
Unless, I mean, there could, of course, be something like bacterial life in our own solar system. And that would be wonderful if that were the case. If you can go to Enceladus and find bacterial life.
Okay, so here's the critical thing about that, and I may be in the minority in my discipline about this, but if we, for example, went to Mars and found life, bacterial life, and Mars, by the way, is turning out to be more and more improbable that we'll ever be able to do that because the surface is so toxic in so many ways. And we've sent spacecraft there over and over and over again, different instruments. We're not finding anything that looks like life. We can't even find liquid water on the surface. But anyway, if we find that Mars had in the past or has now life, and it's identical to ours, I'm not going to be jumping up and down a lot about it because
if it's identical to ours, then it's infection. Then it's cross-infection.
Well,
I mean, if it has DNA and the same DNA code, it's got to be cross-infection.
Oh, that's a question. Is it? Okay, wait. Let me do this in stages.
Okay.
Because of the cross-pollination between the two, that's.
There are meteorites that have come from Mars.
Yeah, we have them. We can see them. Yeah. So that means that life could have been transported. So there are people in my community that would get all excited about that. I'm not going to get excited about it because I think in what we are doing in the planetary program, what people are looking for signals from other intelligent civilizations are doing is we want to know if life got started independently twice.
Yeah.
Okay? That would be far more scientifically interesting than to know, we just exchanged it with another planet. So if we find that Mars life is identical to ours, because of that ease with cross-pollination, it's not going to be too exciting. If we find that it's completely different biochemically, then there's still an uncomfortable aspect of this because could life like ours have gone to Mars and evolved to be different?
Well, let's say if it has DNA and the same DNA code, remember that's 64 codons coding for 20 results, 20 amino acids. If it had that, then it's certainly cross-pollination. It's just too improbable that the same genetic code would arise twice. If it has DNA and a totally different genetic code, that's really interesting.
Wait, DNA and a totally... Oh, you mean like not ACTG, but some other...
That's right, yes, yeah.
And you would still call it DNA?
Oh, yes.
Oh, because DNA describes the...
It could even have A, T, C, and G, but you use different triplet codons.
Excuse me, so I'm lost.
Okay.
A codon is what?
Is 3 letters of the DNA code. And each three letter of the DNA code codes for 1 amino acid in a protein chain.
Oh.
So there are a particular set of these triplet codes which we have, which pretty much must be arbitrary. So if the Martian life has DNA but a different code book, then that means it's independent.
And you couldn't have the situation that you exchange materials, but the environment on Mars was so different in the past that it altered that?
I don't think so.
Okay.
Because the DNA code that we have is regarded as a frozen accident. There's nothing particularly good about it, but once it happened, then it couldn't change, because if you change it, then everything becomes nonsense. If you alter the DNA code, then it becomes total and complete nonsense and nothing works.
Okay.
But I think it's highly unlikely in any case that extraterrestrial life would have DNA. It would probably have something, it would have a genetics of some sort.
There's been a lot of work on this recently, where someone is trying to make synthetic life in his laboratory. And he's pushing, this guy Steve Benner, he works out of Florida, and he specified what the genetic molecule, the molecule that carries the genetic material how it has to behave. And this guy Steve Benner is just extending those concepts, but it's very interesting. I don't know if you've heard of this. It has to be what's called a polyelectrolyte. The individual stations along I don't know the language, so the individual things, in the rails, what are they called? They are sugars and phosphates and so on. What do you call those?
Nucleotides.
The nucleotides, okay. They have to be slightly charged, identically slightly charged, because you need it to be a molecule that serves as a template. And if they weren't slightly charged in the same way, but they were charged, to where they, if they weren't charged or they were charged worse, opposite, then they would just collapse and they would just fold and they'd never be able to serve as, something that could split and, have other things attached to it. So that's, and there were other specifications for it, the chemical behaviors of the molecules in it. It's fascinating.
So he's working out an alternative genetic molecule that's not DNA. Is that a hypothetical DNA molecule?
He's trying to do that, but he's also, because he came to, we in our business kind of invited him to come and speak to us, and we wanted to learn what he was thinking about. He's actually built an instrument. I don't know how far along he's gotten. He's building an instrument that we could put on a spacecraft to just pick up, a bit of the Enceladus plume, which is coming from its ocean, and sample it and put it in his machine, and he could tell us if it has the polyelectrolyte form. We won't know what its biochemistry is. We won't know what the molecules are.
So this would be a way of diagnosing whether when you've been to a distant world like Enceladus and you find a chemical, you can tell whether it has the necessary property to be a genetic molecule.
Yeah, and the idea is you want to see if it has a genetic, it has a molecule like that, because that's the only molecule that could support the whole process of, division, transcription, and so on. So that means it's probably got a living, there's probably biology there. That's the idea.
So when you're going back to Enceladus to have a look?
Not soon enough. Not soon enough, unfortunately. The budgets are...
It might be much more obvious than that. I mean, if there is life there.
Well, I've always been one to say that no one likes this because they just poo-poo pictures. If you're an imaging scientist, they think you're lightweight. So I'm a big one for microscopes. Literally microscopes. You just take a sample and see what's in it.
Yes.
Okay, so let's go on. You, Richard, have had such a remarkable effect on the world of science and the public's understanding of it, and you've left behind some very notable ideas that have just quickly been sucked up by the culture and, incorporated into our language. The idea of a meme, for instance, and the idea of an extended phenotype and so on, which is also the title of one of your books. So for those of us who haven't read that particular book, elaborate on what exactly is meant by an extended phenotype.
The simplest kind of extended phenotype would be an animal artifact, something like a bird's nest. The University of Glasgow has the world authority on animal artifacts, by the way.
They have what?
The University of Glasgow has the world authority on animal artifacts.
Oh, no.
Michael Hansel, yes. So anything where the animal builds something like the bird's nest, the caddis larvae that build these beautiful little houses out of stone, which they cement together and live inside, beavers' dams. All these things are extended phenotypes, and what that means is this. They are clearly Darwinian adaptations. They clearly have been shaped by natural selection to do a job to improve the survival of animals or their offspring, And that means, according to the selfish gene view of life, that genes in organisms have manipulated these artifacts, that there are genes that cause changes in birds' nests, genes that cause changes in beaver dams, genes that cause changes in caddis houses.
So what you mean is genes that are causing a change in the animal's behavior to build these things differently. Okay.
But you see, when we ever talk about a gene for anything, there's always a long, complicated causal chain within the embryology of the organism. So the only thing that genes immediately cause is things like protein synthesis or RNA. But when we see something like a change in tooth sharpness or tail length, that's the end product of a long, complicated sequence of events in embryology. Behavior is just one step further, and the shape of the nest, or the beaver dam, or the caddis house is just one stage further still. So all I'm doing with the extended phenotype is saying we're already quite accustomed to the idea that the phenotype, that which we see, the gene causing, is part of the body, the tail, the horns, the ears, the eyes. This is all familiar phenotype. Extended phenotype is something outside the animal. And as I say, the simplest example of an extended phenotype is an artifact like a bird's nest. But once you've swallowed that, once you've accepted the idea of the extended phenotype as an animal artifact, I then do point out, that animals also manipulate other living creatures. For example, parasites living inside their hosts change the behavior of the host to the benefit of the parasite. There are worms, flukes, whose definitive host is a sheep or a cow, an ungulate of some sort, and they have an intermediate host, which is a snail or an ant or something like that. And it's a different stage in the life history in the ant or snail, and it needs to be eaten by a sheep or a cow in order to get into the definitive host. So what the worm does in the ant is make the ant climb to the top of grass stems where it's more vulnerable to being eaten by ungulates. This is a change in the behavior of the ant, and it's caused by the worm burrows into the brain of the ant and makes a lesion in the brain of the ant, which changes the behavior of the ant in order to increase the likelihood the ant will be eaten by definitive host, which is the sheep. Well, the change in the behavior of the ant is therefore an extended phenotype of genes in the worm, because it is a Darwinian adaptation. If we assume it is a Darwinian adaptation, I think we have to. It's a Darwinian adaptation on the part of the genes in the worm to improve their probability of surviving by getting into the next host, which is the sheep. So we've gone beyond beaver dams and birds' nests to the idea that the extended phenotype works on other animals, in this case an ant. Well, sometimes parasites don't live inside their hosts. There's a chapter in the book about cuckoos. Cuckoos, as you know, lay their eggs in nests of other species, and when the baby cuckoo hatches out, it manipulates the foster parent into feeding it. It has a very attractive gape. It does all sorts of things to make it has a special calls that it makes that causes the foster parent to feed it. So it is manipulating the behavior of the host. It might be a reed warbler, for example. So just in the same way as the worm manipulates the behavior of the ant by making a lesion in the brain, the baby cuckoo doesn't make a lesion in the brain of the reed warbler. It simply makes squawking noises. It does things that are calculated to change the behavior of the foster parent. Well, if you buy that, then you can do the same thing for animal communication generally. When a male ringdove Barbary dove, does a special bow coo display, it coos and bows to the female. This has a direct effect on the female's ovaries, causes the ovaries to swell, and increases and changes the hormonal state of the female. So the male is actually manipulating the female by his behavior. The same thing has been shown with canaries. Male canary song causes female canaries' ovaries to swell, and their hormonal state changes. A male bird might wish, if it could, to make a lesion in the brain of a female bird to change its behavior to the male's advantage. It can't do that. Humans can do that, but birds can't. So what it does instead is it sings. So song is a means of manipulating the behavior of another bird, and you can regard the behavior of the change in state of the female, the change in hormonal state of the female bird, as extended phenotype of genes in the male, because natural selection has favored genes in the male, which cause the male to sing in just the right way to make the female have her ovaries swell. So you can see that the extended phenotype, starting off with easy examples like birds' nests, can be extended to encompass all of or much of animal communication.
Okay, well then you might find this question interesting. Someone on social media, finding out that I was going to be having this discussion with you, wanted to know why you did not consider religion an extended phenotype.
But well, I would not actually, no. Because it is part of the definition that genes in the manipulator change the behavior of the manipulatee. So if it were true that, say, there were genes that caused an individual human to be a very successful preacher, and caused him to change the religious beliefs, the sort of Billy Graham type. If there really were a genetic difference in preaching success, then I might therefore have to concede that something about religion was an extended phenotype. But I'm reluctant to do that because I think it rather weakens the comprehension of the idea of the extended phenotype if you generalize it to that kind of thing.
Didn't your your discussion immediately before, didn't it really point to those things that enhance the animal's chance of survival?
Yes.
So are you saying religion, what is religion? Are you saying religion does something to Billy Graham?
I don't think that, unless it were true that genes in a Billy Graham propagate themselves more successfully because he's a successful preacher, I suppose that might be true.
That could be true. I was just going to say it, and I thought maybe we shouldn't go there, but it's not, but yeah, that probably is true.
Well, yes. Okay. Somebody might like to explore that.
There's a research project out there.
Well, okay. I'm sometimes asked whether buildings like this should be regarded as extended phenotypes, and once again, my answer is probably no, because unless you could show that genes in architects have an effect on their architectural style, which improves the quality, which improves the probability of the gene surviving, then I wouldn't want to call it an extended phenotype.
Okay. Well, so talking about religious belief, this is another area where you've been tremendously outspoken, and I just have a bunch of questions here. So what drove you to take on the mantle of atheism anyway, and become so vocal and write a book that I just learned today was one of Richard's most successful books, The God Delusion? Had you been thinking about it for a while, or was it precipitated by something in particular?
Yes, I had been thinking about it for a while, and I wanted to write it in the late 1990s, and my literary agent, John Brockman, said, "You can't write that book." It won't sell in America. and then 9/11 happened, and George Bush happened. The second George Bush happened, and then John Brockman said, "Okay, you can write it now." But actually, I think that's a rather superficial answer. I mean, the reason why I am interested in religion actually is that the hypothesis that at the base of the universe there exists a creative intelligence who invented the laws of physics and set up the fundamental physical constants, that is a very daring hypothesis, which is false, but if it were true, it would totally change the whole of science. I mean, it is a scientific hypothesis. And so I am against those people like Steve Gould who say religion and science have nothing to do with each other, separate magisteria. Science gets on with with the how of things, and religion is concerned with the why of things, that kind of thing. That's not right. If the religion hypothesis, if the God hypothesis were true, it would be the most exciting hypothesis in science. It's false.
Prove it.
It's false.
Well, if you could prove it.
Yes, but imagine that it were true. Imagine that when you study the laws of physics, you have to You have to consider these were designed by a creative intelligence. I mean, totally different science.
Okay. So let's see. I'm just going to throw in a little story here that's relevant to the role that you played in promoting an atheist perspective through your book, God, Delusion. And of course, you were joined by, there's a whole movement, right? You and it was Dan Dennett and Sam Harris and Christopher Hitchens. You all wrote about the same time, didn't you?
Yeah, we did. We didn't coordinate. It wasn't a coordinated effort.
But wasn't it all precipitated by 9/11 and the irrational?
Maybe it was, yes.
But you did yours in 2006, so 5 years later.
Yes, I mean, but anyway, we didn't think of it as a movement.
Okay, but it kind of turned into one. Maybe. You don't think so?
Okay. Yeah.
Anyway, so Richard and I did an event like this. We did 3 of them in 2018. I don't know what the occasion was. I don't know if it was a book or maybe you were just doing this for your foundation. Mm-hmm. But we went to Calgary in Canada, and we did Dallas in the States and Nashville in the States. And you were signing books at the end. There was big, long lines, like an hour and a half long lines, people wanting to get their book, whatever it was they had, I guess, purchased or something, get you signed. And I had nothing else to do. I hadn't written a book. So I just sat next to you and signed your books.
Did you?
I did. I did.
You helped me sign them, did you? You signed half of them?
No, I didn't sign your signature. I signed my signature.
Okay.
It was even, Robin told me to do it. So I just sat there, but it was really illuminating because person after person after person, I'm telling you, this went on for an hour and a half, was so effusive in their thanks to you for having written the book, having spoken about it, having forced them to question their faith and actually, in many, many cases, just kind of push back against the life they've been forced to lead by their families and their culture and so on. And it was really, really remarkable to me, made a big impression. So I did actually think of the whole thing as a movement. Why don't we hear a lot about it these days? Do you think, are there more, by the way, atheists now than there were when you wrote that book, or where is that?
Well, I think the polls suggest yes.
The polls
suggest yes. In Britain, in Western Europe, Northern Europe, and even America, actually, but they're lagging behind a bit.
I bet. We're lagging behind in a lot.
Yeah.
So, okay, well, so then the big question, what do you think the future of religion will be? Will it ever go away?
I suppose it will eventually, but it may take a hell of a long time. Yes.
What will make it go away?
I think education in science.
The world right now is not going in that direction.
I know, that's right. Well, we're looking forward to see, not looking forward, worrying about what's going to happen in America.
On November 5th. Yeah, but we won't know on November 6th. Don't expect that we'll have an answer on November 6th.
No.
I don't think so. I don't think so.
Well, no.
There'll be lots of challenges.
Lawsuits and
lawsuits,
things.
all that.
I mean, it's all the fault of the Electoral College. If it wasn't for that, there wouldn't be the excuse for...
The Electoral College is just an abomination right now.
It really
is.
is.
Awful.
Yeah.
So you've been very outspoken about a lot of things, and I'm just curious, you're stepping back a bit, you're not going to go on book tours anymore. Are there any issues you promoted or stances that you took during your professional life in the course of your professional life that you either, I would imagine you don't feel regretful for having taken, but, is there anything you would do differently? Maybe you put something a certain way and you felt it got misunderstood and you were forever defending it when in fact you could have said it a different way. Anything like that?
Well, we've already talked about the possibility that the selfish gene was the wrong title.
Right.
But I don't think it was, actually. I've just been asked to write a preface to the 50th anniversary edition of it. And I thought I'm planning to do that by mentioning a series of possible alternative titles it could have had, of which the immortal gene is one. The cooperative gene is another, by the way. And there's plenty about cooperation in...
You mean you actually might change its title?
No. But the preface might list... I might base the preface on a list of alternative titles. The cooperative gene, the strategic gene. There are various possibilities, and they all resonate with the main theme of the book. But other regrets... I mean, I regret... I spent an awful lot of time as a computer programmer when I could have been writing biology books.
What do you mean, as a student or a postdoc?
Well, no. I mean, when in my 30s and 40s, I became obsessed, addicted to computer programming. And
what were you programming?
Well, I was programming models of evolution. They come in the Blind Watchmaker. I invented a computer language. I invented a word. I wrote my own word processor. I did all sorts of ridiculous things because other people do them better. But I was obsessed.
Well, okay. Was it enjoyable? Did you have?
Oh well, in a sort of way, in a way that an addiction can be. I mean,
so this is when you had a position at Oxford. This is what you were doing.
Yes, that's right. I mean, I wrote a program to translate from one language into another. I mean, all sorts of things like that. Oh, I was working on cricket song. I wrote a program to simulate the song of any cricket.
Okay. Did you publish these? Did you do anything with them?
Incidentally, here and there, but not in a big way. Yes.
Oh, okay.
Yeah.
Okay.
So that can be regarded as a misspent time.
Okay, but nothing for which you got, a lot of pushback from the culture at large.
Oh well, no, because the pushback's all wrong. I mean,
okay. But you're right. You're right. I'm just wondering.
Yeah.
Well, I mean, you took a lot of slings and arrows, and I thought, maybe you think, gee, it wasn't worth it. Maybe I shouldn't have said that because, that whole period of time was just terrible, and I could have gotten away with it if I just kept quiet. You don't have that.
No, I wouldn't say that.
Okay.
No.
Okay. So now to a question I spend a lot of time worrying about. It's got nothing to do with what we've been talking about, but I thought it'd be interesting to hear your take on it. And that has to do with the future of our species. So, I mean, actually, it is up your alley because it's maybe about evolution. So I think I told you I was going to ask you about this. So we are, as everybody knows, facing a host of environmental crises, all arising from the destruction that we, our species, are bringing to the Earth's biosphere. Climate change is just one of them. And David Attenborough, in his book, did you read it? A Life on Our Planet, and it's his witness statement. Did you
No,
get
I
to
haven't
read
read
it?
that. No.
You don't know about it?
No.
Oh, so it's actually, it comes at it from a very lovely perspective.
Is it a spin-off from a television program?
I don't think so. I'm glad he did this because I had been wondering like 10 and 15 years ago why David Attenborough isn't stepping forward and
Oh,
talking.
he does. I mean,
No, now he's doing it,
yes.
but it took him a while to
Yeah,
get there,
yeah.
and I was happy to see it. So I eagerly read this book. And he calls it his witness statement, and he's describing, he's been making films for eight decades, So he's been in, that business of looking at the natural world and going all over the globe to places tourists don't go. And he says, over those 8 decades, he's just seen, things just eroding away and things being destroyed. And in this book, he calls attention to 9 environmental crises. And I didn't have a copy of the book with me when I put these notes together, so I can't remember all of them, but they're climate change, biodiversity loss. I'm pretty sure the increasingly limited freshwater supply, overfishing the oceans. I think he put overpopulation on the list and so on. It's alarming. It's really, and he's even now calling it, civilization is over unless we do something about this. So it's, I think everybody is spending a lot of time worrying about this, especially young people, especially people who have kids, thinking of having children. And as I look at this, I see it that we're stuck between 2 countervailing instincts. Okay, we've gotten to this place in the first place because we're responding to our survival instinct. We want to make our lives better, always better. We want to cure disease. We want to prevent disease. We've been successful at doing that, and our numbers increase as a result of it. Fewer people die, and therefore we're using, as a species, more and more resources. And that was okay when there was lots of resources and our numbers were small, but now limits have been reached. And that's what David Attenborough was writing about. And it's like very much, and this is not an analogy that's original with me, we're like rats in a box. Put the rats in a box or a big box, let them procreate, and pretty soon they're killing each other. And so we're competing for those limited resources now with our own kind, and we're destroying them beyond sustainability at the same time. Now, what we can all see is that to solve this we need to all pull globally, we need to all pull in the same direction. We need to figure out how to solve this, whatever it's going to take, reduce resource destruction, change our usage of the way we use energy, agree on the solutions, and then globally act. All going in the same direction. Just act as in unison. And that entails trust, and that entails cooperation. But we can't seem to do it. Because the other instinct, this is just my view, I'm going to ask your take on it. This is my view, that the other instinct is always to be tribal, and always to be worried about our own kind. And to be suspicious of the other. And this obviously conveyed an evolutionary advantage long, long ago, right? I'm not you look different, you might kill me, so I'm going to be cautious. I think that's probably still operative in us. And does anyone really think that we're going to be able to bring someone like Putin to the negotiating table, or the people in China, the leaders of China? I don't. I'm sure he will try. And those countries especially, because they're our biggest competitors, I'm talking about the US, will try to beat us to whatever resources are left. And I think that's what's happening. We all realize resources are going away, but it's like we're all still trying to grab. So it seems to me like an exceedingly difficult challenge that we're very likely to fail at meeting, to expect humankind to change and to step back and see the broader picture that we're all members of the same species, we're living on the same small planet, and that's the way we should regard ourselves, and that's the way we should behave. So, recognizing how large this challenge is and how much of an ask it is of us to go against billions of years of instinct, I'm left feeling extremely pessimistic of our chances of facing and solving these big problems. And because I think we're essentially limited by our DNA. And I just want to know, do you agree with this assessment, and am I right to be so pessimistic?
Well, I agree with everything you're saying. I think I would just add this. We are the only species that's ever existed which is capable of looking into the future. So it's not that other species are better than us in this respect. It's just that we're ridiculously successful in the business of life that all species have been engaged upon. We are the only species that even has the slightest chance of looking into the future and seeing what may happen. Now, I think you're right to be pessimistic, because although it's all very well to say, we can do this, we should do this, we should do that, but who is the we? And the we has to be, as you say, the whole of humanity. And who on earth thinks we can get the whole of humanity to pull together in one direction? It's one thing for scientists. You could probably get a consensus of scientists to get together and say what needs to be done. But then you have to persuade, I suppose, politicians actually to
But politicians
put that into action.
That would be hard to do in the United States. You're doing it between the U.S. and Russia and China.
America first. That's what we're threatened with on November the 5th.
Yeah.
And so, yes, I think you're right to be pessimistic. But if you're asking me for biological insight, it is that we are the only species that ever has had foresight. We haven't got enough of it, but we're the only one that has any at all. All other species evolved to survive in their own selfish way. We have at least a fair number of individuals who have an altruistic look at the future, but there are just not enough of us.
Not enough of us who think that way.
Yes.
Yeah.
Or who have any influence.
So it's bad.
Yeah.
I mean, I don't know why we're laughing. It's bad. It's like, yeah, I just don't know what the solution is. And, and now it seems like, again, stepping back, all the political strife that's going on is, I don't know, maybe even brought about by these tensions. Like, people are just so unnerved by it. And
well, as you say, tribalism is a great menace, and yeah.
Okay, so we're going to move to thank you. We're going to move to the questions from the audience, and this will go on for about a half hour. So, okay. Well, this is cute. If you could go back in time to any period, I imagine that means geological period. When would it be, and what species? What species would you like to see? That's a good question.
Well, I suppose, any child would say the age of dinosaurs, and that's certainly a good candidate. But actually, I think I would go back to the origin of language, not very far, because I'm fascinated by language being, God, look at this, there's hundreds of people here.
I know, there's a lot of people. Yes, good for you.
We are told that all human languages today are highly complicated, equally complicated, yet there must have been a time when they first started, when they were just rudimentary and just beginning, and I'd love to know what that was like.
They just grunted.
Were they just nouns or just verbs, or, I'd like to go back to, I don't know when it would be, nobody knows when it would be, but maybe Homo erectus, and see if they had some kind of primitive language.
I see. This reminds me of another question. I'll go through these. There's an effort to bring back the mastodon.
Yes.
Literally use the DNA found in the, what do you call it? Permafrost, I guess.
Yes.
And what do you think about that?
I'm all in favor.
You
I know
are, even though
a lot of people are
it would be,
against it, but
even though it would be cruel, don't you think it would be?
it wouldn't be cruel, not necessarily. If you had enough of them roving through the tundra.
But they didn't live in a climate like this. It's getting warmer and warmer. They didn't live like this.
Well, no, Siberia, we're talking about woolly mammoths. This is George Church's.
This is what?
George Church.
I'm thinking of hello, Stuart Brand. He's behind it too, I think.
Is he? Okay.
Yeah.
Right.
Okay, anyway. Blah, blah, blah. Let's see. With higher education becoming increasingly more expensive, yes, and universities more political, yes. I mean, I'm just agreeing, it's terrible. What can we do most to encourage rational thought and science? And thanks for being such an amazing educator. But
well, I've spent my life in universities, and I think they're wonderful. But nowadays, you don't actually need to go to university at all. You can do it all on the internet if you have enough dedication. The problem is you don't have enough dedication. You have to. So it is valuable to have somebody supervising you, and I found that actually university, insofar as anything, was the making of me. It was the making of me. What am I supposed to say? I mean, just. What was the question again?
what can we do to most encourage rational thought and science?
Oh, rational thought. Well, I just believe in telling it like it is. Not everybody agrees with me. Some people, I've been taken to task for not being seductive enough, not being persuasive enough. Neil deGrasse Tyson once publicly upbraided me he said, you're supposed to be the professor of public understanding of science, but all you do is just tell people what the truth is. That's not good enough. You've got to persuade them. You've got to seduce them. There has to be an act of persuasion. And he was very eloquent about this. And I replied, well, first of all, I said, I gratefully accept the rebuke. And then I quoted the then editor of New Scientist, Alan Anderson, who I think is a graduate of Edinburgh University. He said, I asked him what his policy was at New Scientist, and he said, our policy at New Scientist is this: science is interesting, and if you don't agree, you can fuck off.
That's what we should have said to David Milch. Asshole wasn't bad enough. Okay, what is the strangest evolutionary mutation you've studied in a mammal? I think I know what no, maybe I don't. Go ahead.
I don't study mutations in mammals myself. Let me think. Mutation?
Well,
do you think you have an answer to that?
Evolutionary mutation you've studied, or what you've seen in a mammal? What's the...
Well, a mutation would be a weird sort of freak. I mean, so it would be something like a calf with two heads. I mean, that would be a mutation. I think maybe
evolutionary, the strangest evolutionary adaptation, maybe that?
The strangest evolutionary adaptation. Well, gosh, I don't know. What about, there's a wonderful maggot, which...
I wouldn't call maggots.
Let me get this story right. It burrows into it lives in Africa, and it burrows into the mud to pupate and then to emerge as an adult insect. And one of the problems with burrowing into the mud is that in Africa, when the dry season comes, you get cracks coming in, sort of jigsaw pattern of cracks. And this, of course, would be fatal to the maggot in its little burrow. So what it does is it does a kind of corkscrew motion round and round and round and round to make a a cylindrical cavity around where it's going to finally burrow down. And this cylindrical cavity means that when the crack comes, it goes around the cylindrical cavity and doesn't tear the maggot in half. So this is a wonderful piece of anticipation, unconscious anticipation by the maggot. There's a similar story of caterpillar which pupates inside a folded leaf. It folds a leaf around itself. And then that's where it turns into an adult. But before it does that, it goes around. It has, in order to make the leaf fold around itself, it cuts with its teeth, with its mandibles. It cuts halfway through the little stalk going to the leaf, which causes the leaf to curl up as it dies. But before it does that with its own leaf, it goes around and does it to lots of other leaves, so that when a predator comes, it doesn't know which one to look in.
Okay. Next question. Do you think the ministers, priests, rabbis, etc., that you've debated actually believe the story they sell?
Yes, I do. But I don't think that many people who call themselves religious actually believe it. I think they often just mean that they're spiritual. They mean that they have a kind of Einsteinian or Carl Sagan-esque reverence. But I think that, well, for example, I've had various discussions with the former Archbishop of Canterbury, Rowan Williams, who's very difficult to have a debate with because he's too nice. And so you can't, it's very difficult to argue with him. And he's also too intelligent, so he finishes your sentences for you. And which means that he knows what's coming, but then he doesn't agree with you for some reason. But I assumed that because he is a sophisticated theologian, I assumed that he didn't actually believe in things like miracles. He didn't actually believe in things like Jesus turning water into wine. So I said, well, obviously you don't believe Jesus turned water into wine. He said, well, yes, as a matter of fact, I do. His reasoning was that he believed in the resurrection, and many churchmen will say that the resurrection is non-negotiable. So if Jesus could do the resurrection, then there's no limit to what he could do. And turning water into wine is just another...
Oh, that was his logic?
Yeah.
You mean the resurrection being that Jesus rose from the dead and passed through a rock?
Well, they all believe that. But then the next step is to say, because he can do that...
Oh, he can do anything.
Then he can do anything.
Okay, well, they got it all wrapped up. Okay, what is the most fundamental question that you feel remains unanswered? And if it got an answer someday, do you think it will affect your entire philosophical worldview of religion and morality?
Well, I think the explanation for the origin of consciousness is the big question for me. I don't even understand what the question means, but I think it's a big question because I feel there's something deeply mysterious about the fact that I know I'm conscious. I presume you're conscious. I presume you're all conscious. But when I interact with nowadays these new artificial intelligences that mimic human intelligence, it's very hard to catch them out and to understand. I mean, I believe they're not conscious. But it's very hard to be sure why. And I suppose I'm committed to the belief that one day a computer program will be conscious.
What does it even mean?
Quite, that's my problem.
Okay, I can't get involved in that whole issue because I just don't know what they're talking about. It's always... So anyway,
well, you have this inner sense that you're a person in there, well, perhaps you don't. I mean, maybe you're not conscious of it.
No, I think I am. I'm not questioning that. I'm just, it's like...
You know the philosophical position called solipsism? That's the belief that only I am conscious and all of you are robots and zombies. Bertrand Russell once had a letter from a woman who said, "Dear Lord Russell, I'm so glad to hear that you're a solipsist. There are so few of us around these days.
The thing about consciousness that puzzles me is, it's not whether you're conscious or I'm conscious. It's they think that atoms and quarks and things like that.
Oh, those people.
Well, those,
Yeah. No, I
Yeah,
mean,
those
that's sort of Deepak Chopra types.
oh, really? I didn't know he was into it too.
Well, they think atoms are conscious, yes. They think consciousness came first.
Consciousness came first. Well,
It's
bizarre. Okay. Do you believe humans have free will? This is like a Sam Harris question.
I'm sometimes asked, which is the question you dread most? That's one of them. The other one is, what advice would you give a young scientist starting out on their career? Do I believe in free will? Do I believe in free will? I always fall back on Christopher Hitchens' answer. I have no choice. I hate that question. I won't answer it.
Okay.
Actually, I don't think we have free will, but I think we have a very powerful illusion that we do.
Okay. Let's see. I think we only have 5 minutes left. Is that true?
Well, I think we started a bit late.
Okay. What has surprised you most in recent evolutionary research?
I suppose the revelation that whales spring from deep within the even-toed ungulates, the artiodactyls, the cloven-hoofed animals. Whales don't have cloven hooves, they don't have hooves at all, but they are most closely related to hippos. And this is an amazing, I think, revelation of molecular genetics.
Molecular?
Yes, because hitherto we did our taxonomy. We worked out which animals were related to what by looking at their anatomy. Nowadays, it's a far more rich source of information. Comes from sequencing DNA and sequencing proteins. And when you do that, it turns out that whales' closest cousins are hippopotamuses. Hippopotamuses' closest cousins are whales. Not, as one might think, pigs or other cloven-hoofed animals. So what happened was that an ungulate, an artiodactyl, a cloven-hoofed animal, went into the sea the way seals do and sea lions and so on, and became so emancipated from land, so freed from the tyranny of gravity, that because they don't even come back on land to reproduce, that it was possible to change so radically that all anatomical traces, almost all anatomical traces of their roots have been effaced.
That's a fascinating story.
Yeah.
And that I don't know what you call it, this idea that years ago people thought whales, you said, no, hippos and pigs were related because they looked similar.
Yes.
So they put them in the same category. In the taxonomy, they went in the same category. And then they they discovered genetics and they were able to show that evolutionarily whales and hippos.
Yeah.
This is very close to me. I mean, I see a lot of similarity between the taxonomic shifts that have happened in the animal world, or whatever just the description of the animal world, and what has been going on in my business as to whether or not Pluto is a planet.
Oh, yes.
Because there are some of my colleagues, I can't believe it, they literally say dumb things like, well, it looks like a planet, so it must be a planet. And I'm going to use this. I'm thinking I'm going to write a paper and use this, it looks like it, therefore it must be related. And in biology, where that turned out to be so spectacularly wrong, and you found that whales and hippos are the ones that are closest.
Well, I think, aren't I right that there are planetesimals in the in the solar system which are bigger than Pluto, I mean, or as big. So I mean, Pluto just doesn't. It's just a matter of size, isn't it?
It's just got no reason to be called a planet except that it was historically. And even back when it was historically called a planet, it was actually politically driven. It was the observatory of Percival Lowell at which it was found, and Percival Lowell wanted to be the guy who said that his telescope was responsible for finding. Isn't that stupid?
Yeah. Yes.
Anyway, the idea is that every taxonomy should have an organizing principle that's obvious and useful. And you guys found genetics, and we in the astronomical community already have one. It's called gravity. Gravity gives us a hierarchy of bodies, and it includes not only their size, well, it doesn't include their size because Mercury and Jupiter are radically different and they're both planets. It's more their dynamical power. And anyway, that's neither here nor there. So I'm actually going to take the last question, and I want to ask Richard, because I think we have about 5 minutes left, and this will probably take, well, I don't know if it'll take 5 minutes, but anyway, and I'm supposed to tell you that that those of you with VIP tickets, you've been instructed what to do, so I don't have to give you any special instructions. And the rest of you, if you want to purchase a book, I don't know if they're still on sale, but I think they're in the lobby. And if they're gone, then I guess you can order Richard's book online probably, right? Yeah. So, okay. So here's the very last question, and I wanted to end it on another story. So 2 years ago, in 2022, I don't know what was going on over here, but the U.S. was overcome with a mania because there was going to be a movie coming out, a feature film coming out about the life of Elvis Presley. And I, being the generation that I'm in, I didn't know much about Elvis. My older brother liked Elvis, but I wasn't an Elvis fan. For me, it was the Beatles. And by the way, I'm using this as an opportunity to tell you how eternally grateful I am to the UK for having invented the Beatles. Really, you guys, they're your best export, in case you didn't know that. So really, they were just overwhelmingly special and lovely and so on. And I'm so glad they were around, but I missed Elvis. And because this movie was coming out and they were making such a big deal about it, I just thought, and now that I don't have a day job, which by the way is the best thing going, not having a day job, I had the time to do this. So I did a deep dive on Elvis. And of course, with the internet, there's just endless information about Elvis. So I saw movies, I read books, interviews, lots of interviews and documentaries, and of course, I'm on the internet. I did this over 9 months. I was crazed. I was obsessed with Elvis. And one website I went to was a website where it was just nothing but what other celebrities had to say about Elvis. And everybody was there. There were people who, grew up with Elvis. I mean, were in his contemporaries, other musical artists. There were people from my generation like Bob Dylan, the Beatles, Jimi Hendrix, Mick Jagger, all the 1960s rockers, even opera singers like Luciano Pavarotti. Everybody had nothing but incredibly glowing comments to make about Elvis. And I just became, I had to, just have a meeting with myself and realize I completely screwed up because I had nothing good to say about Elvis before realizing he was absolutely spectacular. And on this site, there was also a quote of Richard's. And I was stunned. I was like, what? Richard's there quoted as saying that he worshipped Elvis when he was 15. And so much so that one day he didn't know that he thought his home was vacated except for him. He was the only one there. And he was doing a loud Elvis imitation of blue suede shoes. And I thought, oh, now this is an example of fake news. No way Richard would have, I couldn't put Richard in, the same sentence as Elvis Presley. I figured Richard would be listening to Mozart, Bach, maybe Stravinsky, but he wouldn't have been listening to Elvis. So I wrote him an email and said, Richard, you got to take a look at this. These people are misquoting you. And it turns out this came from an excerpt of his memoir, and he did indeed adore Elvis when he was 15. So anyway, this was a knockout for me. And I want to know, tell us, what was it about Elvis Presley that so captivated 15-year-old Richard Dawkins?
I was 15. I mean, that's the answer. We all worshipped Elvis. The episode you're talking about was a great embarrassment to me. I was doing blue suede shoes, and I was walking past the bathroom door where the door was open. My father was in there having a pee, and I don't know whether probably I don't know whether you know blue suede shoes, but it's kind of more said than sung. It's kind of
one for the money.
It sounds
for
vicious.
The show.
Yes,
it get
sounds,
ready now. Go,
okay, that's right. And my father he thought I'd gone mad. I mean, it sounded as though I was sort of had Tourette's syndrome or something.
Okay.
Very embarrassing. I'm not going to do it.
Okay, because he knows that I'm going to ask next that you do a rendition for us. Richard, this is your last tour. This is your very last chance. Okay.
To quote John McEnroe, you cannot be serious.
Well,
the answer is no.
This is the way I'm looking at it. That this could be the start of a new career for you. You could be the next big Elvis impersonator. We could get you a jumpsuit and a cape and a guitar and no.
The idea that there is an actual profession of impersonators of a particular individual is bizarre to me.
Thousands of them. They're all over. Well, okay. I have all of you as a witness that I tried. Okay, I tried, and this is even being recorded, so the world will know that I tried to get Richard to do an imitation of blue suede shoes. And I think on that, I want to end also by saying that now that we're at the end of this gig, Richard, I wanted to thank you for all that you've done for the rest of us. And you've had such an enormous effect on the world. You've pushed harder for science and against illogic and irrational thought than almost anyone else I can think of, all the while suffering slings and arrows and so on for having the courage to tell it like it is. And I mean, I'm sure you must realize it. In doing that, you cut brush for the rest of us, because you made it easier for us to follow, and we didn't have to be as radical as you were because you'd already bowled people over, so we could like just look normal and like we weren't being antagonistic when we told people that there's no God and religion can have detrimental effects. So you really leave behind an incredible legacy, and I'm sure the audience will join me now in rising, and we are going to thank Richard for everything he's done for us. Oh, we have to turn around at once.